So today we're going to talk about, we're going to start a new unit on measurement. So we're going to talk about some perimeter, area, volume, and how that relates to a lot of different shapes. But sometimes when we do perimeter and area and volume, we need to know um, Pythagorean theorem. And Pythagorean theorem is a tool that allows us to find relationships between what's called the hypotenuse and the height in the horizontal distance along the bottom as well. And it's probably one of the more useful tools that we have in society. And a couple things that we need to understand. What do we know about the hypotenuse? Well, it's always opposite the right angle, and it's always the longest side. So we can use the properties of this to build understanding, to understand how to solve for the hypotenuse. Maybe we'll find maybe we have to find one of these legs, and that's okay. One of the reasons why this works, so this is why, is if you add up the areas of the squares of the legs of the right triangle, you get the area of the form to the other side. So here I have 9 squares. Here I have 16 squares. Well, if we move those over here, we actually get 25 squares. And the keyword squares is based on that formula. And you may have seen that formula so far. C is always the hypotenuse. So this is always C. Can't make that big enough for you. Okay. That's always has to be side C. All right, because there's my right angle. Okay. All right. And this works for all right angle triangles. Okay. So we're going to apply this to maybe finding perimeter, maybe finding area. I don't know. But we can solve problems using Pythagorean theorem. That's the goal. So how do we do this? How do we figure out that? Well, one of the things I have to figure out first is find the hypotenuse. All right. And then label it C. So I'm going to go over here and say this is side C because that's the hypotenuse. And then I want to label the other sides. All right. So if I'm looking at this, all right, this could be A and B. That could be interchangeable. But this is always has to be the hypotenuse. So if you mess up on labeling the hypotenuse, that becomes a problem. Always use C squared equals A squared plus B squared. The reason why is we've learned to solve equations. So we know that if we have maybe we have the hypotenuse, we could find one of the legs. Always use that formula. Then I sub in what I know. Well, do I know C? No. Do I know A? Sure, that's 12. 12 squared. B, well, that's 8 squared. Okay. Now I can evaluate each part. So if I look at this, 12 squared, that's 144. 8 squared, that's 64. Okay. now I can add those parts. I can go to my calculator and go say 144 plus 64. And I've got 208. All right. So the question now is, how do I get C? How do I get C equals? Well, I have to do the inverse operation of squaring. Is square root. So then I got to do the square root of both sides. All right. So that's that little button there. So that's 14.4 inches. Okay. And when we do this, let's do a quick check. Well, is 14.4 inches the longest side? Yep, because it's longer than 12 and 8. That makes sense. So use your noggin to be able to rationalize your thinking to make sure your answer makes sense. That's always good. All right, how far up the ladder does the ladder reach? Oh, so we're going to solve for x. But first step is label a triangle. All right. This side is still C because it's opposite my right angle. This side is my hypotenuse. That doesn't change. Okay. This could be my A and B, and that's perfectly fine. Okay. So label the triangle. Use your formula exactly the way you see it. So I have C squared equals A squared plus B squared. But what do I know? Well, I know C is 11, B is 4, and I don't know A. So let's put that in. I have 11 squared. I don't know A. That's fine. B squared, that's 4 squared. Now I can go to my calculator, just like I did up there. Evaluate each part. If I did 11 squared, that's 121. I don't know anything about A. I'll leave it alone. 4 squared, well, I know that's 16. Okay. Well, moving forward, all right, I'm going to use inverse operations. I'm going to use inverse operations to get A by itself. Well, I know that I got to subtract 16 from both sides. So if I take 121 minus the 16, I've got 105. Okay. So again, here, then I'm going to do the square root. So square root of 105 is 10.2 equals A. Okay. So if I look at that and I ask myself, all right, did I answer my question? Yeah. The ladder reaches 10.2 meters up the wall. Okay. So if I'm looking at that, this answer makes sense. The answer makes sense because which one's my longest side? This is still my longest side. 11 is still longer than 10.2 and 4. That's good. So keep that in mind when you're solving problems with Pythagorean theorem, is do a check. Do a check to see, does that make sense? All right. I got to find the perimeter. Well, that's the distance around the outside. Okay. So if I look at this, well, I know that's my C, okay, because it's opposite my right angle. This could be my A and B. Great. I need to find B first. So let's use our equation. C squared equals A squared plus B squared. I can plug in what I know. So there's 30 squared plus B squared. Okay. And then I can evaluate each part. 1156. I can do 30 squared. That's 900. All right. Now I want to use inverse operations right here. Okay. So probably let's subtract 900 from both sides. So I know that this is 256 equals B squared. All right, and then I can do the square root. Okay. So now I figured out that that is 16 inches. Well, guess what I can do with the perimeter? I gotta add up the sides. So I can say this is 30 plus 34 plus 16. All right, so 30 plus 34 plus 16, that's 80. There we go. So hopefully that's helped you. The biggest thing here is make sure that you identify your C, plug in exactly into the formula that you're given, and solve it using inverse operations. Okay. All right. Consider the following equation. Which is the closest to the value of C? So you're looking at this, okay, multiple choice question. Doesn't really matter too much, but let's think about it. All right. If I was looking at this as a triangle, okay. So here, if I'm looking at this, where's side C? Well, that's what I have, right? Let's say that this is 6 and this is 10. So which is the closest? Well, this has to be opposite my right angle, but also has to be the longest side. So if I'm looking at it, if it was 4 or 6, that wouldn't make any sense. Okay. So now we can go and actually try to solve this if we wanted to. All right, so I'm going to push pause here and I want you to try to see what the answer is. So hopefully when you did that, all right, you squared 6 and squared 10, and then you added together, you get 136, and then took the square root. So that is my answer. Okay? So I want you to kind of think about your thinking when you're doing some of this work. All right? Let's see here. All right, let's do one more question and we'll set you guys up. All right. 5 kilometers of highway between X and Y. Okay. There are 2 possible detour routes, one through town A, so they have to go all the way up, and then all the way back. So there's the first detour. The second one is here to here. How much shorter is a detour through B than it is A? Well, what do we have? Well, we have two right-angled triangles. So let's look at town A for a second. Town A, we want to figure out where's my hypotenuse. This is my hypotenuse. So this has to be C. So we're going to say this is A and this side is B here. So we're going to set up that formula. C squared equals A squared plus B squared. All right. And see here. So let's put in what we know. C squared, we don't know. A is 12 and B is 5. So I'm going to push pause here for a second, and I want you to solve for C. So hopefully when you did that, you squared 12, squared 5, add them up to get 169, and then do the square root. All right, get 13. So the detour length through A was to 12 kilometers plus, oh, let's not do purple there. Plus the 13 kilometers to get 25. All right. So it's 25 kilometers there. So town B, what do we know from town B? Well, there's that distance. Well, if I'm looking at town B, where's my right angle? Well, it's right there. Opposite my right angle, that has to be C. The other two sides can be A and B. So let's plug it in. So it really depends on the given information. We know the hypotenuse for this one is 5 kilometers. But for the blue one, it wasn't, because that right there is the hypotenuse across the right angle. Okay, so we know that C is 5 kilometers. A, we don't know. B, oh, it's 3 kilometers. Okay, so I'm going to push pause again and see what you can do to solve for A now. So hopefully when you did that, you squared 5 and squared 3. But the only difference between the blue and the purple here, is I gotta bring the value away from the letter that I'm trying to solve. So this is the solving equation parts that we learned in the earlier learning. So I gotta bring it to the other side. All right, and that's good because this is not my hypotenuse. All right, so my detour length now well, it's the 4 kilometers plus the 3 kilometers. So now, answering the question is not too hard, but the hard part was actually doing the math to get to the answer. All right, so we were asked to find the difference. All right. I think it was 18 kilometers. Okay. Because if I take the difference is 25 minus the 7 that I had. All right. So there we go. So hopefully that's helped you to understand the learning. All right. But this is a good comparison to say, okay, when I'm solving for C, pretty straightforward. When I'm not solving for C or a given C, then I have to think about inverse operations. All right, so it's a very good comparison. So give the questions a try, and we'll talk soon.